Hello and welcome to the 16th topic in the OCR Computing GCSE course videos. We're moving on to looking at relational databases, but quickly before we start, this may not apply to everyone depending on when you're watching this, but I haven't uploaded in about a month over the Christmas winter period. I try to get as many videos out before the year 11 or year 10 depending on when you have them mock exams. Hopefully they went well if you did them, and now I'm going to get as many videos as up. I've just finished the course in as quick a time as possible. I'm really glad to see people are using these videos and revising early. That's really impressive to see, and I'm glad they're useful, so I'll do my best to get them up as soon as possible, starting with this video. So speaking of which, let's get straight into it. So first, let's define what a relational database is. So a relational database consists of tables that link together with each other by key fields. We're going to look at key fields in more detail in a couple of minutes time, but initially, if we've got this is a relational database, ignore the arrow, that's just me showing how they're linked together by the subject ID column. This is the key field that I'm talking about here, but like I say, we'll look at this in more detail in a second. So we've got two tables here. This could comprise a database, or this could comprise part of a relational database. It would be very small if it had only two tables, but it would still technically be a relational database because it's linked together by subject ID key field. But let's leave that for a second and just define a few terms before we get started. First of which, we're going to look at what an entity is. So these are the things that data has been collected about. So in this context, the entities are the subjects, the teachers and the times, and we've got data here. It may not look like data has been collected, but in this context it may not have been, but in most contexts you'll just have some data to do with the entity, e.g. the subjects and teachers. And this, to define a table, should be quite simple, but it's slightly harder than maybe you think because it's just quite a simple word. But a table is a two-dimensional representation of data that's stored in rows and columns. And the OCR specification asks you to understand the relationship between entities and tables, and this confused me a bit because I wondered whether they were talking about something quite simple or more complex, and I was trying to work out what exactly they meant. It's slightly hard to sometimes work out what the exam board are asking of you, but I think this should cover that. Cover every base, hopefully. So what I've said is the tables contain the data from the entities. So the table bit does contain the data from the entities stored in rows usually. So usually the column headings are the entities and the rows contain the data associated with them. So that's what I assume they mean by the relationship. I may not be looking into this as deeply as they want, but hopefully that's what they mean. But definitely what they do want of you, they want you to know what a form is. And forms are what data is submitted to the database in. So this is putting data into the database. And the opposite of that is a query. And a query is a request for data from a database, so data is taken out of it, it's retrieved, as opposed to putting it in with a form. And queries we have to look at in slightly more detail. You're fortunate in this course, compared to the AQA course, you barely have to know much about queries. You don't have to know any languages as you do in AQA, so that's a massive positive for you. But you do need to know about what reports are in very basic terms, and a report is a presentation of data from the database, and this may be a third-party software. The way I would maybe think of it, even though Microsoft Excel isn't a database software per se, you can have tables, and you can use the data in the tables to create graphs and I don't know, pie charts, for example, and that would be a report if you're looking at it from that example. And finally, let's just define what a module is. You may have come across modules when you're programming, and modules are things that add additional functionality to a database that isn't built in at the start. So just add some additional functionality, and it's slightly hard to give an example because it does very much vary in what you're doing exactly, but just add something that isn't built in at the start. Okay, so I mentioned we're going to look at queries in slightly more detail, but we're looking at them in terms of logical operators and how we frame database queries. That's the term we use, frame, as in writing queries. So different words and symbols called operators are used in order to retrieve data that's wanted. They help make the queries more specific, so you get exactly what you want. And we're talking about operators in terms of these three different types. This is how I would sort of separate operators. And when we talk about logical operators, the natural ones that come to mind are the Boolean operators. We looked at these in maybe even the second topic in this series. Maybe it was the first couple of early videos about logic circuits, and we looked at Boolean operators and, or, and not. Very key and used a lot, as are arithmetic operators. Maybe not so much, because in databases you're not really going to be dividing stuff too often necessarily, but comparison operators are used a fair bit, and we'll look at a few examples here. What I've done in this slide, I've just adapted some SQL code. That stands for Standard Query Language, and this is just a programming language for databases, but you don't need to know about, like I said before, the AQA course. Unfortunately for them, they have to know a bit about SQL. I've just adapted some SQL into some pseudocode style language. So just to show you some examples. So here we've got code that uses the AND operator. And what this does, this retrieves data both from the entity's name and birthday from table 1. So because it's AND, it's both. It's for data both from them, not or, not obviously. So it's AND in that query. So another query using a arithmetic operator. We're using a asterisk here, a star, whatever you want to call it. And in SQL, this means all. It selects everything. So instead of doing something specific, it just selects everything from table 1. And if we just quickly have a look at, we've got words here, select and from, and we're also going to have where in a second. And these are clauses. They're called clauses, and they're not strictly operators. Operators are something that compares two things together. I know we've got comparison operators here, but if you think about it, what this is sort of doing is comparing something. Maybe it's not so much of all, but if we're using divide or and, it is comparing two things together, and that's what an operator is. And a clause just helps build up this statement. So finally, a slightly more complex example here. We're using two operators, a comparison one and a Boolean one. And what this does in SQL, these two, a greater than and less than sign next to each other, this means not equal to. You could also use a exclamation mark and an equal sign if you're using pseudocode, your informal just representation. You can also use that. I just thought if you see that, don't get confused, that just means not equal to. So what this does, it retrieves the data from either name or ID. Notice or is either, not both. From table 1 where the age is not equal to 20, so you won't get any data where the age is equal to 20 using this query. So yeah, hopefully that covers this specification point. You don't need to know too much specifically about anything about SQL or maybe how to write queries, but it's very important to know this and some of the examples of the operators, especially Boolean operators. That's absolutely key. Okay, so let's move on to looking at something called data redundancy. And this is when data is unnecessarily repeated in two or more tables. So data is repeated where it doesn't need to be. And clearly this is inefficient. Hopefully you know what that means. It's where resources haven't been allocated in a proper way. And this data redundancy should not occur in a well-designed database. So let's look at examples of data redundancy. So we've got two tables here in a relational database. They're linked together by the code key field. And what we've got here, we've got two repeats. We've got Mr. Jones and Miss White, are repeated in both tables, and they don't need to be because they're linked. They don't need to be repeated twice. That's an inefficient way of storing something. It's wasting storage space because it doesn't need to be repeated twice. Because of key fields. And let's just define what a key field is. You may not know. A key field is a unique, that's important, identifier in each table that links that table to at least one other. So in this example, code is a unique identifier. It's a key field. It's unique and it links to this table. So a primary key in one table is a foreign key in another table. And if a specification doesn't mention this, again, for people doing the AQA course have to know about this, but I find it will make it slightly easy to understand. So if you look at one table, the primary key in one table is the foreign key in another table. So if we're looking at this table, this is the primary key and it's linked to a foreign key in this table, and this primary key is linked to another foreign key in another table. So if we just look at these two tables without the redundant data, you can see we've got a column missing. This doesn't need to be repeated because we've already got it here. We don't need it again. It's sort of pointless to be there again. And so yeah, they show the same thing, except there's no data redundancy, there's no inefficient storage here, and everything is not repeated, nothing is repeated except the key field, but that's what links it together, that needs to be there for it to be a relational database. And in this scenario, code is being used with a key field like we said, because it links the two tables together and is unique for each row. It needs to be unique, otherwise it's not a key field. So give this a read if it's confusing. It is slightly confusing, which is good. So yeah, make sure you read it again if you're slightly confused. Okay, moving on. Finally, let's look at input validation. So depending on the function of the database, not all databases will have the capability to do this. There may be an option for a user to input data to it. So depending on what the database is for, you may have a user that inputs something to it. And validation, what this means is validation is the act of checking something to make sure it is correct and reasonable. So if we're looking at in this context with databases, it is to make sure the data inputted is not going to cause errors when added to the database. So this could be many things. We're going to look at a few methods in a second, but what this does, validation makes the database more robust. And if you don't know what robustness is, and it's the ability to cope with errors. It's a key term in this course. Recommend you use it whenever you can in your controlled assessments and maybe even the exam, but make sure you know what robustness is. And it makes it more robust because it's less likely to break, because errors they're sort of removed at quite an early stage if validation is done. And there are quite a few methods of input validation, some of which apply to databases, which we're going to look at in a sec. But you have input validation in just normal programs, but we're looking at databases. The following apply, and this is definitely not an exclusive list. This is just a couple. The course doesn't specify whether you should know any ones in particular, but these are some really important ones I'd recommend you know. So first of which is data type validation, and this ensures the input is a specific data type. So unfortunately, the order this course is in, the data type video comes up slightly later, but data type is the classification of data. So you've got characters, you have integers, you have Boolean values. It just classifies things separately. So if you're having a age column in a table, you want to make sure that every input to that column is an integer. You don't want it to be, an integer is a whole number. You don't want it to be a letter inputted into an age column, because that may cause an error if you're doing some kind of calculation. And that's not robust. Another validation method is range check, and this checks that the input is in a specified range. So for example, if you're doing a column that's maybe a date, like a day of the month, then you want to make sure the input is between 1 and 31. You don't want someone inputting 35 as a day or 0 as a day. That's just not going to work. It may cause an error to happen. You also have something called a null check validation method, and this makes sure that the database field isn't left blank. Often if you've got web page input, it won't let you select next or confirm if you leave some fields left blank, and that's what the null check validation method is doing, because your input is going to go to a database somewhere and it needs to make sure that no field is left blank. And finally, one we're going to look at, the length check validation method. This makes sure that the input is above or below a length limit. So an example of this is with passwords. Passwords are stored in an encrypted database, and often you'll be forced to do a minimum length of password. For example, you can't have a password but 0 length, and this could be the same as null check, but it also may make you do 5 characters minimum as a password, and if you do less, maybe something would go wrong. That's what it does. That's why it validates your input. So basically that's it for today's video. I've spoken really fast over quite a short period of time, relatively speaking. It is a potentially confusing topic, so make sure you go over it. If it is confusing, feel free to ask me questions. My email is in the description, or comment, whatever you need to do, and I'll do my best to answer your questions. Hopefully it was helpful. And yeah, thanks a lot for watching. Next up, we're looking at networks, slightly more interesting in my opinion. So yeah, hopefully I'll see you then.